Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Subject is matrices and calculus. Today, we are going to discuss the topic on the diagonalization of a matrix and powers of the matrix. That means diagonalization of a matrix and powers of a matrix. And before going to discuss the diagonalization of a matrix and after that powers of a matrix, first of all, we need to understand what is the meaning of the diagonal matrix. If you remember the diagonal matrix, then the problem is easy to do that. That means by using whatever the concept is there, then easy to understand. The diagonalization of a matrix. The diagonalization of a matrix is nothing but, as per the definition, it should be non-diagonal elements are 0. That means if it is a 3 by 3 matrix, the diagonal elements are, these are the diagonal elements. That means the diagonal other than the non-diagonal element should be 0. That means here whatever it is there, these are the diagonal elements. Based upon the procedure, we need to reduce it to according to the non-diagonal elements are 0. While we are proceeding this method, we need to reduce it to diagonal. That means the diagonal elements are occur. Here, we need to again remember the diagonal elements are the eigenvalues of the matrix. That means according to the definition of the diagonal, the non-diagonal element should be 0. The diagonal elements should be occurrent. Here the diagonal elements are the eigenvalues of the matrix. Then what is the procedure? Then how to find the solutions? And here, before going to discuss, in the previous lectures, we discussed clearly from the given any matrix, how to find the eigenvalues. That means, first of all, how to find the characteristic equation. And again, how to find the eigenvalues. And again, how to find the eigenvectors. And based upon that, at the time of here, the diagonal matrix are also, we need to discuss compulsory based upon the characteristic equation and eigenvalues and eigenvectors. Because of based upon the characteristic equation and eigenvalues and eigenvectors, we need to discuss further proceeding this today class, that is the diagonalization of the matrix. In previous sessions, we discussed briefly about that one class is how to find the characteristic equation, how to find the eigenvalues, how to find the eigenvectors, and again how to verify the Cayley-Hamilton theorem that based upon the applications. But today we are going to discuss the diagonalization of a matrix. But here also, first of all, we need to understand, again we need to recall what is the characteristic equations. That means how to get the characteristic equations. Here, for example, there is any matrix. It is considered that is a 3 by 3 matrix. And again, I is any unit matrix, and again lambda is any scalar. And with the help of these three, if it is treated as box, that is a matrix of A minus lambda I, is called the characteristic matrix. And similarly, from this A minus lambda I, if it is finding the det, that means based upon the A minus lambda I, if we found that is a determinant of A minus lambda I, we get in the polynomial equations. That polynomial equation is called as a characteristic polynomial. And further, by getting this is the characteristic polynomial, by equating this polynomial is equal to 0, then we need to get the characteristic equations. Now again further, by solving this equation, we get the solutions. That solutions are called the eigenvalues from the given corresponding the matrix A. And here, for example, again, we need to recall few points, that is how to get the characteristic equation from the 2 by 2, and again how to get the characteristic equation from 3 by 3. That means, for example, it is a character, if it is a matrix is A11, that is under the 2 by 2, and according to the 2 by 2, according by the definition of the data of A minus lambda is equal to 0, the lambda square minus S1 lambda plus S2 is equal to 0, where that S1 is nothing but it is a sum of the diagonal elements. That means sum of the matrix, the diagonal matrix, or it is also nothing but the trace of the matrix. The sum of the diagonal elements are also nothing but it is a trace of the matrix. And here it is a determinant. That is the meaning of S2 is the determinant of the matrix. That we know that how to find the 2 by 2, that is by using the S2 is equal to, that is AD minus BC. This is by the condition of, that is the determinant of the 2 by 2. And further the 3 by 3. The 3 by 3, we need to require the third order equations, that is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. And moreover, here also, in the previous sessions like that, s1 is the sum of the principal diagonal elements, that is the sum or trace of the matrix, and s2 is the sum of the minus of the diagonal elements, and s3 is the determinant of the matrix. And that also we know that how to find that, that s3 is the determinant of the given matrix, that we know that in general method. Based upon all these values, we need to replace in the characteristic equations and we find the solutions. The solutions are called the eigenvalues. And now coming to, we'll discuss the diagonalization. That means we need to recall these are the some definitions and these are the some important points. And based upon this one, we need to further the diagonalization of a matrix. And what is the meaning? Just now I said that is the diagonal is nothing but it is the non-diagonal elements are 0. That means we need to occur. It is a 3 by 3, for example. These are the 3 by 3 and 0, 0 and 0, 0. And it is nothing but the non-zero element is lambda 1 and lambda 2 and lambda 3. These are according to the processor. We need to reduce it to, that is a diagonal element should be the eigenvalues of the particular given matrix. And here, and is it possible to the diagonal? That means before going to discuss again here how to define the diagonal matrix, this is according to the definition like that by the processor of the diagonal matrix. For example, if a square matrix A of order n has n, that is a linearly independent eigenvector, that is eigenvectors are treated as x1, x2 up to so on xn, that depend upon the matrix corresponding to the eigenvalues. That means here the eigenvalues are nothing but, as you know, that consider like the lambda 1, lambda 2 up to so on lambda n respectively. And again, then a matrix P, that means then a matrix P. And what is the meaning of this one? First of all, we need to find out that lambda 2, lambda 3 up to so on lambda n, and corresponding we need to find out like lambda 1 is equal to x1 and lambda 2 is equal to x2 up to so on. This is the xn. And whatever you get, that is the x1 and x2 and x3 like that. If it is treated within the like matrix, this is matrix is known as a pizza matrix. That means it is a x1 and again x2 and xn, x3. For example, this is the 3 by 3 matrix. That means from the given any matrix, we need to find out the eigenvalues and corresponding eigenvectors. That eigenvectors are we can consider in the matrix. That matrix is known as a model matrix. Can be formed such that it's whatever we obtain the P, and with the help of the P, we need to find out P inverse into AP. We get the matrix. That matrix is known as a diagonal matrix. And that means according to here, when we are going to reduce or define the diagonal matrix, here first we need to find out what is the eigenvalues and corresponding eigenvectors. Then we need to formation of the matrix. That is a matrix formation of matrix is a P, that is treated as a model matrix, and from that we need to find out what is a P inverse, and after that the product of P inverse into A into P is equal to, we get the D is a matrix. The D is called as a diagonal matrix, and here according to the diagonal matrix, the diagonal element should be satisfied the eigenvalues of the matrix. And further it is denoted by the D is nothing but it is a P inverse into AP, and again here P is known as a model matrix, where it is a collection of the 3 eigenvectors is called as a model matrix. It is denoted by the symbol is a P. And D is the diagonal matrix known as a like spectral matrix. That means then the resulting diagonal matrix is known as a spectral matrix. And again here we need to recall that spectrum. The spectrum is different from the spectral. The spectrum is nothing but it is a like collection of eigenvalues. And spectral is nothing but that is a collection of eigenvectors. Sorry, spectral is nothing but the resulting diagonal matrix D is called as a spectral. The collection of eigenvalues is called as a spectrum. And again here the diagonal matrix whose the diagonal elements are the eigenvalues of the matrix A. That means here what I am saying like that D is the matrix is nothing but the diagonal matrix, here collection of lambda 2, lambda 3 and lambda 3, and again it is a clearly we obtain according to by the processor of it is a P inverse into E into P is the matrix. Based upon this processor we can obtain that is a diagonalization of the. And further we need to verify here the finally the D is equal to, we need to remember P inverse into AP, and P is known as a model matrix. And again, the D is a diagonal matrix whose the diagonal elements are like eigenvalues, and diagonal matrix whose the diagonal elements are the eigenvalues of the given matrix A. And here we need to remember the conditions. What are the conditions we need to remember under this diagonalization of a matrix? Here, first one, an n by n matrix A is a diagonalization. That means when it is possible, like the diagonalization. That means when it is a diagonalization of a matrix. That means every matrix is a diagonalization. That is not like that. That means every matrix is a not diagonal matrix. And based upon this remark condition, then we need to remember. And n by n matrix A is a diagonalization if and only if. That means A is a diagonalization if and only if that n is a linearly independent eigenvector. And that meaning, what is the meaning of this one? The linearly independent. The linearly independent is nothing but the data of, as the per the definition, the data of is not equal to 0. That means the data is not equal to 0. And the meaning of here, whatever you get, that means first of all we need to find out the lambda 1, lambda 2, for example lambda 3, and based upon that you need to find out x1 and x2 and x3. This the data of this x1, x2, x3, that is a 3 by 3, is not equal to 0. Then only it is a diagonalization is existed. That is the meaning of a matrix is a diagonalization if and only if that n linearly independent eigenvector. That means it should be that is not equal to 0. For example, it is that is equal to 0. The meaning of here, it is a p is equal to 0. And at the time of the p is equal to 0, the p inverse does not exist. Because of that p, if it is a p is equal to that is not equal to 0, then only p inverse is exist. And further proceeding the problem. But here, if it is a p is not equal to 0, then p inverse it is existed. Therefore, it is a diagonalization is exist. And due to that reason here, whenever the n linearly independent eigenvector, then only it is the matrix is the D is a diagonalization. Otherwise, it is not a diagonalization of a matrix. And second one, what is the second one? If the eigenvalues of an n by n matrix all are distinct. That means, in other terminology, whenever eigenvalues are different eigenvalues, that means whatever the characteristic equation, by using the from the characteristic equation, after finding that we get some value. The values are called as eigenvalues. That eigenvalues are different. The different is nothing but it is called as a distinct. The distinct, the terminology is nothing but it is a different. That means whenever the eigenvalues are the different, then automatically the matrix is a diagonalization. And similarly, here the necessary and sufficient condition for a square matrix to be diagonalization is that the geometric multiplicity of each eigenvalue is the same as the algebra multiplicity. And what is the meaning of this? Here, one is the condition that n linearly independent eigenvectors, then also the function, the matrix is the diagonalization. And second condition, if the matrix is all are the different eigenvalues, that also the matrix is the diagonalization. And third condition, whenever the particular eigenvalues of the algebra multiplicity and geometric multiplicity, the both are also same, that time also the matrix is said to be the diagonalization. Other cases, that is AM is not equal to GM is, that is not a diagonalization of a matrix. That is the meaning of AM is equal to GM. That means algebra multiplicity is equal to the geometric multiplicity. Then the matrix are also clearly satisfied the diagonalization of the matrix. That means we need to remember these are the three conditions. That means when the matrix is the diagonalization means one is the linearly independent eigenvectors are diagonalization. Second one, the matrix, the different eigenvalues are also the diagonalization is possible. The third condition, the particular eigenvalues of the geometric multiplicity and algebra multiplicity is equal to same. That time also the matrix is satisfied the diagonalization. These are the three conditions we need to remember. And here, for example, here, what is the procedure to finding the matrix is a diagonalization or not? That means according to based upon, we need to flow chart to remember. based upon the previous slide, we need to observe here. When any matrix is given, the matrix is a diagonalization or not. That means we need to remember this is the flow chart like that. First of all, we need to find the eigenvalues. For example, eigenvalues are different. That means the eigenvalues are distinct. Then automatically the matrix is satisfied the diagonalization of the matrix. In case sometimes the eigenvalues are not equal, that means the eigenvalues are repeated. That what is the meaning of the repeated? That means, for example, eigenvalues are, for example, 1 comma 3 comma 5. It is automatically by default it is a diagonalization. And for example, the eigenvalues are repeated, means 1 comma, for example, 1 comma 2. For example, in the matrix. And here, whenever the eigenvalues are repeated like this, then according to we need to check what is the find the algebra multiplicity and geometry multiplicity. That means what is a particular eigenvalue of 1, what is the algebra multiplicity and also geometric multiplicity. And similarly, the eigenvalue of 2, what is the algebra multiplicity and geometric multiplicity of that particular eigenvalues. And again, if both are same, the particular eigenvalues of the eigenvalues, the AM and GM both are same, then also the matrix is said to be, that is a diagonalization of a matrix. And for example, that particular eigenvalue of 1, algebra multiplicity is 2, the GM is also 2, then it is also eligible. And for example, the eigenvalue of that 2, the algebra multiplicity is 3, the geometric multiplicity also 3, then we get the matrix is said to be, it is a diagonalization of a matrix. And further, we need to discuss some problems. Here, what is the procedure? First, okay, procedure for finding the matrix P and P inverse AP. That P is nothing but it is a model matrix, and P inverse in DAP is nothing but we get the matrix is a D, that is nothing but it is a diagonalization of a matrix. Then what is the procedure for this model matrix and also P inverse in DAP? That means here, first of all, find the eigenvalues and corresponding eigenvectors. That means according to that given any matrix, first of all, we need to find out what is the particular matrix eigenvalues and eigenvectors. As we know that how to find the eigenvalues and eigenvectors from the given matrix, that is with the help of the characteristic equations. And after that, construct that P, that is writing all the linearly independent eigenvector as column vectors. That means first of all, lambda 1, lambda 2 and lambda 3 is the first step, and further lambda 1 is equal to x1 and lambda 2 is equal to x2 and lambda 3 is equal to x3. That is a collection of this is the matrix is the up to the second step. And after that, we need to find out what is the P inverse. That means from this P, we need to find out that is the P inverse. And based upon that P inverse into, again that P inverse into AP, then you find out whether it is a diagonalization or not. That is a clearly procedure to find out according to the diagonalization of a matrix. This is the working rule. And here the diagonal matrix in T is equal to P inverse into AP will have the eigenvalues of on its main diagonal. Note that the order of the eigenvalues P will be determined of the eigenvalues which appear in the main diagonal. And that is the meaning of whatever we obtain the diagonal matrix, that is the diagonal elements are the eigenvalues of the given matrix. And here procedure to find out what is the Taylorian. That means whatever we obtain the D is a matrix, from the D matrix, here how to find the powers of the matrix. This is also applications under the diagonalization of a matrix. And again here, as we know that D is going to P inverse AP. For example, D square, that means D into D. That means P inverse into AP into P inverse AP. Therefore, P inverse into A square P. And similarly, for example, D cube. And as you know that P inverse into A cube into P. And in generally, D power n. Again, based upon the previous two steps, that is P inverse into A cube into P. And again, from this equation, A power n is nothing but P into D power n into P inverse. That means we need to remember the D is nothing but P inverse into AP, and A power n is nothing but P into D power n into P inverse. That means we know that what is a P and what is a P inverse. inverse. P is nothing but it is a collection of eigenvectors, that is a model matrix, and P inverse is nothing but adjoint of P by or something that P is also, that is our choice. And again after that we need to remember here diagonal matrix, whose the diagonal elements are eigenvalues of the matrix. That is a diagonal matrix of clear matrix. Okay, and again notes. What is the conditions? Here conditions. Yeah, that is a d power n is nothing but the powers of the eigenvalues of the matrix. For example, we need to check whether the following matrices are diagonalization or matrix. Means first we need to discuss under the 2 by 2 whether the matrix is the diagonalization or not. That we need to check it first of all. The simple problem we need to check it first one. Here the problem is given the order is 2 by 2. It is simply asking that it is diagonalization or not. According to that, finding that checking the diagonalization or not means based upon the eigenvalues. That we need to understand. The eigenvalues are nothing but according to while we are going to finding characteristic equation, that is delta of a minus lambda I, that is a lambda square minus s1 lambda plus s2 is equal to 0. And in this, S1 is the trace of the matrix and S2 is equal to the data of the matrix. And by using the calculation of this one, that S1 is the trace of is nothing but it is a 10 minus 2 is nothing but 8, and S2 is the determinant of the matrix, and clearly it is a 16 is the value. Therefore, we need to replace here in the equation 1. The equation is reduced to like this, and again from this equation we need to solve. The lambda is equal to here. The problem is 4, 4. And here, while we are going to observing in these eigenvalues, we need to find out what is the eigenvector. Here, according to the flow chart or something, the condition, whenever the eigenvalues are different, it is directly possible this. But whenever the eigenvalues are repeated, we need to check according to what is the particularly the value of I, what is a particular eigenvalue, what is the geometric multiplicity and algebra multiplicity. And we need to confirmation. If it is both are the same, that is AM and GM, then the matrix is automatically diagonalization. But we can't say the matrix eigenvalues are 4, 4 is then automatically the eigenvalues are same, then the matrix is not diagonalization. It is not like that. Whenever the eigenvalues are different, automatically the matrix is a diagonalization. But whenever the eigenvalues are repeated, we need to check particularly wherever whatever the eigenvalue is repeated, that particular eigenvalue, what is the algebra multiplicity, what is the geometric multiplicity. And the meaning of here, the algebra multiplicity is nothing but whatever the eigenvalue. For example, it is a 4 is eigenvalue, it is repeated. Here, what is how many times it is repeated? That is 2 times. Therefore, the algebra multiplicity of the particular lambda 4 is equal to 4 eigenvalue is 2 is the algebra multiplicity. Therefore, algebra multiplicity of 4 is nothing but it is 4 is repeated 2 times. Therefore, the algebra multiplicity of 4 is equal to that is a 2 value. And we need to check out what is the geometric multiplicity of the particular eigenvalue of lambda equal to 4. That means we know the formula n minus the particular eigenvalue of the lambda is equal to 4. That is a formula n minus rank of a minus for a minus lambda I. That means the geometric multiplicity is nothing but n minus the rank of a minus lambda I. And the meaning of n is nothing but here that is n is a number of variables. In this given matrix, the variables are that is a 2 because of the 2 equations means that automatically it is a 2 variable. Therefore, n is equal to that is a 2 conditions. And minus, we need to find out the rank of a minus lambda I. That rank of a minus lambda I means first of all a minus lambda I. That a minus lambda I, we know that the meaning of a minus lambda is nothing but it is A is a given matrix, I is a corresponding unit matrix, and 4 multiplication. Therefore, the matrix is reduced to here. It is A matrix, and based upon this one, 10 minus lambda minus 4 and 4 minus 2 minus lambda. That is the meaning of it is this one, and in that particularly that lambda is nothing but 4i. Therefore, we obtain this the 4 is the matrix, and A minus 4i is nothing but the first matrix is 6 minus 9. and again 4 and also that is a minus 6. And based upon this one, here while we are going to reduce it to echelon form, that means we need to find out the rank of this particular row of A minus lambda I. That particular lambda is equal to 4 is the value. Therefore, here the rank is first equation is divided by with 3, and again the second equation is divided by 2. Then automatically rank is it will be 1 is the rank. Therefore, we need to check according to that whatever the equations like according to based upon this one. The rank is nothing but it is a 4 is a rank. Rank is equal to 1 is a rank. And here this is the rank of A minus 4i is equal to that is a 1 value. But we need to find out n minus rank of A minus 4i. And n means that is a 2 is a number of variable. Therefore, from the second equation, it is a n minus rank of A minus 4i. Or n is equal to 2 minus 1 is the rank of A minus 4i. Therefore, here that particularly GM is nothing but we obtain the 1 is the value. That means here conclusion that algebra multiplicity we completed, that is identification, that is a 2. The geometric multiplicity it is a 1 value. But according to the concept, the AM is not equal to GM, that particular value of lambda is equal to 4. Therefore, this matrix is not a diagonalization of a matrix. This is a clear example for that. The matrix is a diagonalization or not. If it is a diagonalization, how to find out? If it is not a diagonalization, this is the clear the problem. Here, finally, we need to remember the matrix eigenvalues are the different, automatically exists the diagonal matrix. The eigenvalues are repeated. We need to check the particular eigenvalues. What is the algebra multiplicity and geometric multiplicity? For example, this matrix are also, is it the matrix is a diagonalization or not? First, as per the working rule, we need to find out the characteristic equation. And again, S1 is nothing but that is 0 and S2 is nothing but minus 12. As we know that how to find all these conditions, that previous class we discussed that clearly. And here lambda is equal to lambda square is equal to 12. That means lambda is equal to plus or minus that is a 3 into 4, that is a plus or minus 3 into 2, that is a root 3, that is a plus or minus 2 into root 3. And here the meaning of the eigenvalues are that is 2 into root 3, and again it is a it is a one of the eigenvalue, it is a 2 eigenvalues, one of the eigenvalues is 2 into root 3 and minus the other one is a root 3. By the conclusion itself, here directly the problem is asking like whether it is a diagonalization or not. That means according to the concept of whenever the eigenvalues are different, then automatically the matrix it should be diagonalization of the matrix. And moreover, these are the plus and minus, the both the eigenvalues are the different eigenvalues. Based upon this condition, if all the eigenvalues are the different, distinct, that means that is a different, then the matrix is automatically diagonalization. Therefore, here the matrix is clearly it is a diagonalization of a matrix. Yeah. And further, we need to check. Find the eigenvalues according to they are asking to find out V inverse into AP into P. And here the matrix is the lambda square according to the 2 by 2 general equations, the S1 and S2. Up to here, easy to get the problem. Lambda is equal to 1 comma 3. Sorry, 1 minus 1 comma 3. And it is clearly the eigenvalues are different eigenvalues. That means lambda is equal to minus 1 comma 3. The different eigenvalues. Automatically, the according to the working rule of the diagonalization of the matrix, it should be, it is clearly existed. That means diagonalization. Now we need to find out that corresponding eigenvectors, particularly lambda is equal to minus 1. As we know that in the previous sessions we discussed clearly, that is how to find the eigenvectors corresponding either the equation format or something Gauss elimination method. We need to find the solutions. But now here in the previous sessions we discussed the eigenvectors with the help of the equation format. But here I am given that other method, that is a Gauss elimination method. Yeah, here. That is a Gauss elimination is nothing but it is a back substitution method. Yeah. One of the eigenvector corresponding lambda is equal to 0, lambda is equal to minus 1 is a 0 comma 1. And we need to keep other side like lambda is equal to 3 also. Same based upon the characteristic equation by using the Gauss elimination or any like equation format we get the solutions. Finally, here also, yeah, that is 1 comma 2 is also we need to consider. 1 by 2 comma 1 or something 1 comma 2 is also that corresponding eigenvector of the lambda is equal to minus 1. Therefore, here conclusion of the eigenvectors are one is a 0 comma 1 and other one is 1 by 2 comma 1. And according to that diagonalization, if we need to find out, we need to find out what is a P matrix. That P is nothing but the collection of the eigenvectors together within the single matrix. Therefore, P is equal to the first eigenvector is the first column, the second eigenvector is the second column. And from this, by the procedure, we need to find out what is the P inverse. And we get, actually in this problem, in the previous problem only they are asking find the eigenvectors and diagonalization of a matrix and find the A power 4. While we are going to do that here we need to observe properly the matrix is under the 3 by 3. That means first of all we need to find out what is the eigenvalues and also eigenvectors. And in previous like 2-3 sessions we discussed clearly how to find the eigenvalues and also how to find the eigenvectors. This is the eigenvalues are calculated with the help of the characteristic equation based upon this one. Regarding all these problems, we discussed in the number of problems in the previous lectures. Yeah, it is a 2 comma 3 comma 6. And according to the working rule of the diagonalization of a matrix, the after finding the eigenvalues, first of all we need to observe here the eigenvalues are the different. That means it is a diagonalization of a matrix is existed. And now further we need to find out corresponding lambda eigenvalues, what is the eigenvectors. Therefore, lambda is equal to 2 eigenvalues corresponding eigenvectors. This is a clearly we shown in the we discussed in the previous sessions. That is the one is a lambda equal to eigenvector is clearly by using the equation by taking any two equations like 1 comma 2 or 2 comma 3 or any 1 comma 3. By solving that we obtain that the eigenvalues are eigenvector is nothing but 1 comma 0 comma minus 1. And similarly we need to find out that lambda is equal to 3 also the corresponding eigenvector. Here also by using the equation format here by solving any 2 and 3, that is a different equations we need to assume that. Here also by while we are going to observing here the eigenvectors corresponding lambda equal 3 is a 1 comma 1 comma 1 value. And similarly we need to find out the third eigenvalue corresponding eigenvector lambda is equal to 6. And here also that clearly by using the equation format by taking any two equations, it is 1 comma minus 2 comma 1 is a value. And based upon that we need to find out further. The further step is whatever we get the eigenvalues and corresponding the eigenvectors, we should consider within the matrix. That is the matrix is the P is the matrix. Therefore here eigenvalues are 2 3 6 and corresponding eigenvectors are the 3 1 by 1. The values are 1 0 minus 1 1 1 1 and 1 minus 2 1. That collection of three eigenvectors we need to consider the model matrix. We are together within the matrix. Therefore the P is denoted first eigenvector and second eigenvector and the third eigenvector. This is the collection of together these are the three linearly independent eigenvectors because of the eigenvalues are different eigenvalues. And we need to find out what is the P inverse. Here according to in this P inverse, that is our choice, we need to find out that is a inverse of the matrix or something any Gauss Jordan or like any Gauss elimination method we need to find out. And here P inverse is equal to we obtain that clearly that is a matrix. And next further step, whatever we obtain the P inverse, and here by the procedure we need to calculate the P inverse in DAP. The P inverse that we know that P inverse is the value is the here above the matrix inverse matrix, and E is the given matrix, E is the given matrix, and P is the here model matrix. And based upon this one, after that multiplication of individually that one by one these are the matrix, we obtain clearly the matrix is reduced to like 2 3 6 by obtain that according to after these are three matrices we obtain that clearly. And after the dividing that 1 by 6 also we clearly that 2 0 0 0 3 6 0 0 0 6. And while we are going to observe here that the matrix the product of that P inverse in DAP is we obtain that D matrix. That means the other values are clearly we obtain the zeros. That means the non-diagonal elements are the 0. And according to the non-diagonal elements, it is what we are going to observe here. The diagonal elements are, that is 2, 3, 6. And where we are going to observing these diagonal elements are also clearly satisfied the eigenvalues of the matrix. Eigenvalues of the matrix is equal to the diagonal elements are equal, that is 2, 3, 6. And further, we need to find out what is the powers of the matrix. And as we know that the powers of the matrix, that A, that we know that D is equal to P inverse into AP, that A is equal to P into D into P inverse, and but we require the powers of the matrix A power n is equal to that P into D power n into P inverse. And again, we need to find out the problem is A power of, it is a 4 value. That means it is a D power of 4 into P inverse. And again, we P here P, that P is nothing but it is a model matrix, and P is equal to, that is inverse of the model matrix, and D power 4. The D power 4 is nothing but, just we need to observe here, that is a P is this is the model matrix, and here P inverse, that is the inverse of the model matrix, and D power 4. The D power 4 is nothing but the diagonal elements are the eigenvalues. The eigenvalues are 2, 3, like that 6. Therefore, this diagonal matrix we need to find out D power 4 only. That means that is a 2 power 4 and 3 power 4 and also 6 power 4. By calculating these are the 2 power 4 and 3 power 4 and C power 4, we need to replace in the middle of the D power 4. Here we obtain the 2 power 4 is nothing but 16, and D power 4, 3 power 4 is 81, and 3 power 4 is nothing but 1296. This matrix we can replace in the middle of the place. And now again we need to product. This is the matrix. Therefore, this is the required the matrix according to from the given matrix, the diagonalization, as well as this is the powers of the matrix. And similarly, we need to find out the diagonal matrix A. First of all, we need to find out what is the, as we know that according to how to find the eigenvalues and also eigenvectors. Here eigenvalues are calculated according to, these are the steps. And again here, as we know that how to find the 1 by 1 S1 and S2 and also that is S3. The eigenvalues are here clearly minus 1 comma 2 comma minus 1 by using the any other methods. Here also that we can up to that according to. See here, while we are going to observing in this particular, the eigenvalues are, it is particularly minus 1 comma minus 1 comma 2. And in this problem, whereas in the previous problem, the eigenvalues are different, it is easy to exist it. But in this problem, the eigenvalues are minus 1 is a repeated and 2 is the eigenvalues is a different. But as per the concept, whenever the eigenvalues are different, the matrix is clearly the diagonalization. The matrix is repeated. We need to check the particular matrix, the particular eigenvalues are what is the algebra multiplicity and geometric multiplicity. But here 2 is eigenvalues is single. Therefore, we are not going to concentrate here. We need to find out what is the eigenvalue of lambda is equal to minus 1, what is the AM and what is the GM of that is a minus 1 value. And here minus 1 eigenvalue is nothing but it is a 2 value. Because of minus 1 is repeated 2 times. Therefore, the algebra multiplicity of minus 1 is nothing but 2. And again here, we need to find out the particular GM, that means geometric multiplicity of the particular value of lambda is equal to minus 1. With the help of the formula n minus of, we need to find out this one. It is a n minus of, it is by using the formula n minus of, that rank of n minus the rank of A minus lambda I. That means n. N means, as we know that is here the problem is a 3 variable because of the 3 by 3. Therefore 3 minus the rank of, that is A minus lambda is equal to, it is here minus 1. That means minus of minus is nothing but plus into 1 is the value. That means we need to find out what is the rank of A plus I is the value. And again that also rank of A plus I also we need to find out with the help of either the Gauss elimination method or any by equation format. First of all, we need to find out A plus I is the value. That means we need to find the value of A plus I. And after finding that, we need to replace that subtraction with n minus, then find the solutions. For example, rank of A plus I. While we are going to rank of A plus I means first A plus I. A is nothing but the given matrix. I is nothing but unit matrix. That means addition of that A is a matrix and plus I. That means it is A plus I is a matrix. While we are going to addition of the like addition of the diagonal elements, we obtain this one. Directly we can say that the matrix are all the rows are same. That automatically the rank of this matrix is the one is the value. Even if we need to calculate with the help of the Gauss elimination method or any other that echelon form, the matrix is reduced to that is one is the rank. And conclusion here, A plus I is the rank is 1, but we need to find out n minus of rank of A plus I. That means n is equal to, we know that is a 3. And again, a 3 minus 1 is nothing but that is a 2 is the value. And here the conclusion already we discuss, already we identify AM is the 2 and here GM is also 2. Therefore, AM is equal to GM. Therefore, the matrix is clearly the diagonalization of a matrix. And further, we need to find out what is the powers of the matrix, like according to what is the eigenvalues of the particularly the lambda is equal to 2 by using the equation format or any other method we discussed in the previously that how to find the eigenvector. Here the lambda is equal to eigenvectors is 1 comma 1 comma 1. We need to find out the corresponding lambda is equal to minus 1. What is the eigenvector? It is also by using the equation format. Here, while we are going to observing, these are the two equations or three equations are same. We need to assume consider any one equations. By taking the one equations, here n minus r. And what is n is equal to? That is 3. And r is nothing but rank is 1. That means n minus r is equal to, here when we are finding the eigenvectors, here we need to remember n minus r. And again it is n is nothing but it is a 3 and r is nothing but it is a 1 is the rank of the matrix. And that means it is n minus r is nothing but it is a 2. Therefore, based upon the 2, that we need to assume the two arbitrary constants while we are going to finding the eigenvectors of the given particular. Therefore, let us assume that x3 is equal to k1 and x2 is equal to k2. And based upon that, from the equation 1, we obtain that x1 is equal to minus of k1 plus k2 because of n minus r. Therefore, n is equal to 3 is a variable and r is a 1. Therefore, it is a 2. Therefore, n is nothing but k1. We need to assume that k2. And based upon this is the logic we need to find out here how to find the solutions. Here we need to take the two different eigenvector by taking a clear concept of this one into k1 and k2. The first row it should be k1 is multiplication with minus 1 and second row it is there is no k1 and again third row k1 is the value is 1. Therefore, from the first one it should be 1 and again second one k is there in no term 0 and the third term k1 is equal to 1 is the value. And similarly, other one k2, that first row is the k2 coefficient is a minus 1 and again k2 second one is a 1 value and again k3 in the third row the value is a 0. Therefore, here we need to assume that these are the two eigenvectors. And based upon the first eigenvector and also second eigenvector, we need to consider in the matrix notation. The matrix is nothing but it is eigenvalues are these are the particular eigenvalues and also eigenvector. Next, further, the problem is finding the diagonal matrix. Therefore, that B is nothing but the collection of the three eigenvector. Here, one is the collection of eigenvector is nothing but first eigenvector is 1, 1, 1. We need to replace. Second eigenvector is minus 1, 0, 1. The third eigenvector is minus 1, 1, 0, minus 1, 0. Therefore, it is from this matrix. Then we need to find out what is the P inverse. Therefore, the P inverse is equal to, as we know that how to find that, either the adjoint availability or any Gauss method or Gauss elimination method. Here by calculating P inverse is equal to, we obtain like this. And further, the diagonalization of the matrix. The diagonalization of the matrix is a P inverse into AP. Therefore, that we know that P inverse is this the matrix and A is the given matrix and P is the collection of eigenvector. Here, the one by one the product of these three matrices. Here, we obtain the output matrix. What is the final matrix? The final matrix is nothing but the diagonal matrix. The diagonal matrix is nothing but the diagonal element should be satisfied. The eigen values of the given matrix. Here, the eigen values are corresponding. First is a 2, second is minus 1, third is a minus 1. This is the matrix. And further, we need to find out what is the powers of the matrix. Here powers of the matrix they are asking to find out. Here with the help of this one, a power n is equal to p into d power n to p inverse. But the problem is a power 4. That means we need to replace in branch of n is equal to, that is also 4 value. Therefore, here again p. As we know that the p is nothing but the model matrix, and p inverse, that is the inverse of the matrix, d power 4. That means 2 power 4 and minus 1 power 4 and also the minus 1 whole power 4. These are the diagonal elements should be power of the 4. That means it is 2 power 4, minus 1 power 4 and minus 1 power 4. Here d power 4 is nothing but 16. And again the minus 1 power 4 is a even number, that is 1, and minus 1 power 1 is a, so 4 is also 1 value. This particular matrix can be replaced in this d power 4 matrix. And again by using the product of these three, we obtain the matrices after the total simplification. Then the matrix is reduced to a power 4 is this the matrix, that is a 6 5 5 5 6 5 and again 5 5 6 is the final matrix. And further we need to find out same the matrix conclusion of this one, the problem. In this problem here, up to here no problem. The GM of in this particular problem, GM is equal to 1. But the conclusion of in this, EM is equal to 1, it is equal to GM is also 1. Therefore, the matrix it should be, that is a diagonalization of a matrix. And particularly that lambda is equal to 1. But here lambda is equal to 2. That lambda is equal to is nothing but, the GM of this is nothing but, in this problem, by using any Gauss elimination method or Gauss Seidel method, reduce to echelon form. After that confirmation echelon form, your rank is 2, but it is also GM is n minus rank of A minus 2i, therefore 3 minus 2. But in this problem, it is a AM is equal to 2, I think GM is equal to, that is a 1 value. Therefore, AM is not equal to GM, at particularly lambda is equal to 2. Therefore, this type of the problem, it is a the matrix is the not diagonalization of a matrix. That means according to the working rule of the diagonalization of a matrix, we need to recall one is whenever the eigenvalues are different, that automatically the diagonalization of a matrix. But eigenvalues are different, that is repeated. We need to check that particular whatever the eigenvalue is repeated, that particular eigenvalues we need to find out what is the algebra multiplicity and geometric multiplicity. In case the algebra multiplicity and geometric multiplicity is same, then a matrix is a diagonalization. But if the algebra multiplicity is not equal to the geometric multiplicity, therefore the matrix is a not diagonalization of a matrix. And similarly, we need to find out according to all these problems. And again further, we need to discuss in the next class, that is a mean value theorem. Here any clarifications or any doubts, please give me the reply in this link. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.